Hello everyone, welcome back to the next lecture in the computer network series, and today we will see the vertical redundancy check, simply VRC. Let's start the session with the outcomes. In today's session, we have two outcomes. Let's see what are they. Upon the completion of this session, the learner will be able to outcome number 1, know the various types of error detection methods. Outcome number 2, we will understand VRC and its performance. Let's start the session by knowing the various error detection methods. We are going to address 4 error detection methods, and they are VRC, LRC, checksum and CRC. Let's focus on VRC in today's session. VRC stands for Vertical Redundancy Check. It is also known as parity check. We will see what is a parity check with an example. Suppose if this is the data that we would like to send to the receiver. In other words, let this be the data the sender generates. It is of 7 bits, 11000001, and this is obviously the data that is generated by the sender. Now this data is given to the event parity generator. An event parity generator accepts this data and generates a parity bit. Now what this event parity generator does after accepting this data? This event parity generator checks for the number of ones that are there in the data. 1, 2, 3. And there are 3 ones and 3 is an odd number. So what it does, it creates the VRC, that is the redundant bit, which is called as a VRC bit, as 1 here. Because this 1 indicates that there are odd number of ones in the data. Odd number of ones mean there may be only 1 1 in the data, or 3 ones, or 5 ones, or 7 ones. Now in this case there are 3 ones, so it generates 1 as the parity bit. So this parity bit is also called as a redundant bit, and here it is called as a VRC bit or parity check. It appends this 1 with the data and sends that to the receiver. So the data that is transmitted is 11100001. We can notice here this is what the original message is, and this is what the VRC is. Now this is what the information is sent to the receiver. If there are no errors during transmission, the receiver receives this information as 11100001. This is what this information is. What the receiver does, it checks for even number of ones in the received message. If there are even number of ones in the received message, the receiver understands that there are no transmission errors. Whereas if the receiver sees that there are odd number of ones in the data that it has received, it understands that the message was prone to transmission errors and it rejects this. We can also understand this in other way. It means the receiver knows this bit will be the parity bit. So it places this bit aside and it checks for how many number of ones in the actual message. In this case there are 3 ones. So it knows 3 means it is an odd number. So it checks for the parity bit whether it is 1 or 0. For 3, if it is 1 here, the receiver understands that there are no transmission errors. Though this VRC is a very simple process, but there are serious drawbacks with the VRC. Let's analyze the performance of VRC. We know very well that there are 2 types of errors. One is the bit error and the other one is the burst error. Let's check how far VRC is capable of handling bit errors and burst errors. It can detect single bit errors. It means if only one bit that has been changed during transmission, VRC is very powerful enough in detecting the errors. The probability of having bit errors during transmission is very minimal. So there are chances for burst errors. How far VRC is good in handling or detecting the burst errors? It can detect burst errors only if the number of ones is odd. We will understand these 2 things with an example now. In this example, let's assume that the sender is creating this message. It means this is what the original message is and this is the parity bit. Now this message is transmitted over the transmission medium, and let's assume that the second bit is modified as 0. That is, this bit is modified as 0. Now the receiver receives this bit and it checks whether there are even number of ones in the message that it has received. Now in this case 1, 2, 3. There are only 3 ones. It means it receives odd number of ones. So the receiver rejects this data or the message because it accepts only even number of ones. In this case, it receives odd number of ones. It understands that there is a single bit error and it rejects this data. What if 2 bits are changed? Let's see that now. The second bit is modified and the 6th bit is also modified. That is, this bit is modified. In the data that it was created by the sender, it was actually 1. But during transmission, this was modified as 0. This bit is 0 here, whereas here it is 1. So in this case, the number of errors is an even number. There are even number of errors. Now what if the receiver receives this data? The receiver checks for even number of ones. Now in this case, 1, 2, 3 and 4. Since it has received even number of ones, the receiver misunderstands that there are no errors in the transmission, so it accepts the data. But actually this message is erroneous. In other words, the receiver can also do like this. It can take this bit, it knows this is the parity bit, and it takes this bit aside and checks for the number of ones. 1, 2, 3. So there are 3 ones. So it understands 3 means it is an odd number. So it checks for the parity bit as 1. Since the parity bit is also 1, it misunderstands that there are no errors during transmission and it accepts that data. If the number of errors is odd, VRC can detect. But if the number of errors is even, VRC cannot detect this. So that is what it is given here. It can detect single bit error, or it can detect burst error, that is group of bits can also be modified only if the number of errors is odd. Before concluding this session, let's have an homework problem. Append the parity bit after each block shown below using VRC technique. We are required to append the parity bit after these 3 blocks. Try this so that you can become proficient with VRC. And that's it guys. I hope now you know the types of error detection methods and you understand VRC and its performance. Thank you guys.